Welcome back, science fans. Today, we're diving into a complex and ultimately terrifying topic: how a hydrogen bomb works and what happens during the first 30 seconds after one explodes. I'll break it down step by step to give you a clear picture of the science behind it. First, we need to understand what makes a bomb nuclear. These weapons use the energy stored in atomic nuclei, either by breaking them apart in a process called fission or by forcing them together with fusion. How is so much energy released from a single bomb? Well, consider the equation E equals mc squared. This formula, crafted by Albert Einstein, says that energy equals mass multiplied by the speed of light squared. The speed of light is a huge number, and when you square it, the resulting energy is astronomical. Convert even a tiny amount of matter directly into energy, and you get an idea of the incredible potential locked within the atomic nucleus. This is very different from conventional warheads, which rely entirely on chemical reactions for their explosive force. Those explosions are peanuts compared to what happens in a nuclear reaction. Now that we understand where all this energy comes from, let's imagine a scenario where a missile carrying a bomb hurtles through the sky toward its target. As it closes in, highly advanced automated systems get to work. These systems are programmed to execute a sequence of events with absolute precision. When the missile reaches a predetermined altitude and distance from the target, the first crucial step is initiated: the detonation of a conventional explosive surrounding the nuclear material. These conventional explosives serve a critical function. They compress the nuclear material, such as uranium-235, into a super-dense state. This compression is essential for initiating a fission chain reaction, releasing an enormous burst of energy in the form of X-rays. At this point, a chain reaction within the nuclear material begins, causing the nuclear bomb to explode, creating the iconic mushroom cloud that rises into the distance. However, with a hydrogen or fusion bomb, things go a step further. If a fusion fuel container is inside the missile, typically made up of hydrogen isotopes like deuterium and tritium, the process doesn't end here. The X-rays generated by the fission reaction strike uranium-based casing that holds the fusion fuel. This generates a high-pressure plasma environment where atoms are so energized that they're essentially a soup of ions and free electrons. This plasma compresses the fusion fuel, creating a secondary, far more powerful fusion reaction. The conditions inside this compressed plasma are extraordinarily hot, even compared to the initial fission reaction. We're talking about temperatures that can reach millions of degrees Fahrenheit. This extreme heat and high pressure create the perfect environment for the fuel to undergo nuclear fusion. Once this happens, an enormous amount of energy that's far more than fission alone is released. This is why the term thermonuclear is used. Thermo refers to heat, and that's key here. This mind-boggling release of energy occurs in mere milliseconds, quicker than the blink of an eye. The explosion generates a force that doesn't just dissipate into thin air. The energy has to go somewhere, and it does so in a highly organized yet utterly destructive manner. It transforms into various forms, including thermal radiation, light, and of course, the shock wave. In the initial 2 seconds, the fireball starts its rapid ascent and expansion. The heat it emits isn't confined to the immediate vicinity. It radiates outward, setting everything within a 2-mile radius ablaze. In the next 3 seconds, the shock wave races out, covering several miles from the point of detonation, known as ground zero. The force unleashed is a tempest of apocalyptic proportions, as if the very wrath of the gods has been uncorked. Buildings don't just crumble, they disintegrate into confetti, while trees are uprooted and hurled skyward like matchsticks caught in a whirlwind. The shockwave tears through the landscape, rewriting the very fabric of reality. In 5 more seconds, the blast wave continues its rapid expansion, reducing everything it encounters to rubble. The fireball is a growing, glaring beacon of destruction. At the same time, fallout, comprising radioactive debris, is beginning to rise into the atmosphere. As we approach the half-minute mark, the fireball loses its upward momentum and forms the familiar mushroom cloud shape. And while less potent than in the first few seconds, the shockwave continues to wreak desolation. Buildings, trees, and other structures are destroyed or severely damaged, making the landscape unrecognizable. So what happens to life within a 2-mile radius? Unfortunately, the outcome is as bad as you can imagine. The intense heat would instantly vaporize any living thing, even before the shockwave hits. This isn't just a fire, it's like being at the heart of a star for a brief moment. For those within a 5-mile radius who manage to survive the initial explosion but are still wandering around outside, they're as good as dead. The initial burst of radiation would deliver lethal doses. Within hours, symptoms of acute radiation sickness would appear, including severe nausea, vomiting, and a rapid decline in cognitive and physical abilities. Adding to this grim outlook, fallout begins to descend. This material, which is dust and debris from the explosion, is highly radioactive and will soon cause severe radiation sickness. Everyone outside will be dead within days. Even if someone miraculously survived for longer, terminal cancer would almost certainly follow. And there you have it, the first 30 seconds after a hydrogen bomb explodes. If you want to watch more, click the video below to watch a hypothetical nuclear missile strike on Washington, D.C. If you found this video informative, please give it a thumbs up and subscribe for more content like this. Thanks for watching. Until the next time.